Okay, problem 6 here has us working with a position. So it starts at is an initial position. So let's call that S0. Okay. Initial velocity V0 and subject to a constant acceleration. So that's going to be our A. And note that these are both two-dimensional vectors. But hopefully you remember that we said we could work this as two one-dimensional problems. We want to end up with the speed when it's at its maximum x position. We've worked a homework problem like this and a lecture problem. This is the important concept that a lot of people miss. This maximum x position happens or occurs when the velocity in the x equals 0. Sort of like our tennis ball going up to the peak and then starting to come back down. The point where in the tennis ball's case, the y velocity is 0 is the peak or the maximum y. So same thing for x. So the key here is to write an equation for v sub x, which is actually very simple. For constant acceleration, v sub x is v sub x0 plus a sub x times t. Okay, we said that we want to find the time at which v sub x is 0. That's going to give us our maximum x position. So this is finding time when v sub x equals 0. Alright, so our vx0 comes from right here. Okay, initial velocity for the x component. So that's going to just be 3. And our a sub x comes from our acceleration component. Minus 2 times time. Alright, solving for time. 2t equals 3, t equals 2/3. I can't even do math. That should be 3/2. Should have done it in the calculator. Let's erase that. 1.5. How's that? So at 1.5 seconds, we're at our maximum velocity. Excuse me, at our maximum x position. The velocity in x is 0. Okay, we want to determine the speed of the object when it's at that maximum position. We already know one component. Okay, v sub x is 0, so now we need to find v sub y. V sub y at t equals 1.5. Okay, because the speed is going to be the combination of those two components. And so that's going to be simply the same sort of equation, vy0 plus at. Let's see, so velocity in y at time 1.5 is going to be our initial velocity in y plus our acceleration in y times our time. Let's see here. 7 plus 6 times 1.5. I could have done that in my head too, but I would have probably made a mistake. So 16, no, it's not seconds, 16 feet per second. Okay. So the total velocity is square root of vx squared plus vy squared. But in this case, it's just also 16 because Vx is 0. Okay, this one was a very easy problem if you understood the concept. You didn't need to use any information about S0. We were asked for the speed. Okay, if we were asked for position, we would have had to plug in our time into constant acceleration equations and get X and Y positions and then work with those. But in this case, very easy, 16 feet per second. Speed when the object is at its maximum position.